Today we are going to discuss multinomial theorem. This theorem is similar to binomial theorem. So let's quickly review binomial theorem. Binomial theorem uses only two variables. So this expression can be expanded using binomial theorem as nc0 a to the power n, nc1 a to the power n minus 1b, nc2 a to the power n minus 2b square, and so on. Last term would be ncn b to the power n. For example, if I take a plus b to the power 3, my expansion would be like this: 3c0 a to the power 3 plus 3c1 a to the power 2b plus 3c2 ab square plus 3c3 b cubed. We can notice here that left hand side has total power of 3. Right hand side also, each term has total power as 3. This a is having power 3. This is giving me 2 power and this variable is giving me 1 power. So total power is again 3. This variable is giving me power 1. This variable is giving me power 2. So again total power is 3. And here I have 3. And these are binomial coefficients. Similarly, we have multinomial theorem for more than 2 variables. For example, I can take similar example: a plus b plus c to the power 5. Suppose I wish to expand this. So first of all, I need the terms. What kind of terms I would be having here. Second thing, what should be my coefficients like these? We call multinomial coefficients. So let's see first what kind of terms I would be having here. I would be having like a to the power 5, which is giving me total power of 5, because left hand side is also having power 5. I might also have a to the power 4 into b, that is also giving me 4 plus 1 is 5. I may also have a square b c square. This is giving me 2 power, this is giving me 1, this is 2. So 2 plus 1 plus 2 is again 5. So why don't we calculate how many terms are here? In binomial, it's easy. I always have terms n plus 1. If n is the power to the left hand side expression, then right hand side will be having n plus 1 terms. You can see in this example, I have 3 here. So 3 plus 1 is my 4. I can see 1, 2, 3, 4. It's easy because binomial coefficient starts from 0 and n till n. So starting with 0 to 1, 2, 3 dot n, the number of terms would be n plus 1. But here in multinomial expansion, this is not as easy as it looks in binomial. So let's first calculate how many terms would be here in this expression. We can use some combinatorics methods, maybe sticks and stones. So let's take 2 sticks so that I can separate my 3 variables. So these are my 2 sticks and making 3 boxes for a and b and c. And I place my variables here a, b and c. And these power 5 I can take as stones. So I can distribute my stones in these 3 boxes like this. Either all my 5 stones are here, or maybe 1 stone is here and 2 stones are here. I am left with 2 stones. I can put my 2 stones in box 3. Or maybe I can have no stone here like this, and I have 3 stones here and 2 stones here. What it means? It means that my expression would look like, this expression would look like all stones are in this box. So I have a to the power 5 because I'm distributing powers to variables. So this would be like a to the power 5. And here it would be a, b square, c square. And in this row, I would have no a but b cube and c square. So all my terms would be like this, as we explained just now. So how many sticks I do have? I have 2 sticks and 5 stones. So how many ways I can arrange these 7 items in factorial 7? Since I have these 2 sticks are indistinguishable and 5 stones also indistinguishable, I need to divide this factorial 7 by factorial 2 and factorial 5. So total number would be 7 into 6 into factorial 5 divided by 2 into factorial 5. I cancel factorial 5 by factorial 5. I cancel 6 by 2. I get 21 terms. We can also verify that are we getting 21 terms. Let's see. I can number like this 1, 2, 3, 4, 5, 6. So let's start writing expressions. A to the power 5, a to the power 4 into b. Maybe I can take variable c also with a to the power 4c. You can see total power is 5, 5, 4 plus 1, 4 plus 1. If I further reduce a to the power 3, I can have 2 power from b square, or I can also have like this b and c square. No, it will be c only because I need only 5 powers. Then I can have my a cube c square, total again 5. I cannot have any other expression with a 3. Let's have a square b3. I can have like this a square b square c, a square b c square. 2 plus 1 plus 2 is 5, or I can have a square c cube. And we also calculated that we have number of terms as 21. Now we are going to calculate coefficients, multinomial coefficients. So we calculate like this. We take numerator as factorial n. In our case, it's factorial 5. Whatever power we are calculating to the left hand side, this would be my numerator. And in denominator, I will do k1 factorial, k2 factorial, k3 factorial. What are these k1, k2, k3? K1 is a power of a, k2 is a power of b, and k3 is a power of c. So suppose I want to write the coefficient for this expression. A b to the power 4. Numerator would be factorial 5 in all cases. Denominator would be 1 factorial, b to the power 4, so 4 factorial, c to the power 0, so 0 factorial. So let's write the final expression of a plus b plus c to the power 5. This will have 21 terms. Let's write few of them. So a to the power 5 and coefficient would be factorial 5 over factorial 5 into factorial 0, factorial 0. Second term would be a to the power 4 into b, factorial 5 over factorial 4 into factorial 0, factorial 1 into factorial 0 plus a to the power 4c, factorial 5 over factorial 4, factorial 0, factorial 1, and so on. Maybe the last term I can write c to the power 5, factorial 5 over factorial 0, factorial 0, and factorial 5. So we can take few more examples, and finally we will write the general expression for multinomial. So if I take a plus b plus c plus d to the power 7. So terms would be starting like this. A to the power 7 and numerator would be factorial 7 upon factorial 7 for power of a, factorial 0 for power of b, factorial 0 for power of c, factorial 0 for power of d. If I take any of the expression, something like that, a to the power 5 b square is giving me total 7 power. So I cannot add more variables here. Numerator would be factorial 7 divided by factorial 5, factorial 2, and rest of the coefficients are having power 0. So I would write like that. If I put my expression like this, a 3, b, c, so I got 3, 4, 5 power, 2 more, d square, then its coefficient would look like this. Factorial 7 divided by factorial 3, factorial 1, factorial 1, and factorial 2. So this 3 is my factorial 3. This power 1 is going to be factorial 1. Power of c is my factorial 1 here. Power of d is my factorial 2 here. So in general, we can write the multinomial theorem like this. We can see here that this is multinomial coefficient. These k1, k2, k3 are nothing but power of variable x1, x2, x3. And this is the multiplication of variables such that sum of all power should be n. I hope this is clear. Thanks for watching.